Well, hello scrappers, gold lovers, welcome back to my channel. Mike here, and this is another one of these viewer request things dealing with the stuff from Mount Baker Mining and Metals. I have a whole series of videos where I've been experimenting with this stuff, and you guys said you didn't want to just see the finished product, you wanted to see, you know, the behind the scenes, the experiments, the intermediate results, the bloopers, the flops, the failed experiments, and whatnot. Okay, so this is another video about that. I don't know if what I'm about to do is going to work or not. We're both going to find out together. This is an experiment I would normally do off camera, and if it worked, I would probably repeat it on camera for you guys. If it didn't work, well, I might move on to something else. So we'll give this a try and see how it goes today, okay? So, a quick backstory on this stuff, where I got it, where it came from. My friend Ken, up in BC, Canada, he's a scrapper. He has a lot of e-waste up there, and he sent a couple of gaylords of old PC motherboards to Jason at Mount Baker Mining and Metal. Jason ran those motherboards through his process up there, through his hammer mills and across his shaker table. And what I've got here is a big bag of the #1 concentrates off of Jason's shaker table from those motherboards. So this is going to contain all the precious metals that was in those motherboards, but it's also going to contain all the base metals and junk metals and a bunch of other stuff that's in here. So yeah, and I've been experimenting with this stuff pretty heavily. Got a whole series of videos. I'll put a link in the upper right to one of my recent ones. You can check that out if you like. And what I found in my last few videos where I've been experimenting with this stuff is that the main problem I am having is with the tin. There's a lot of tin in here, okay, from the solder on those motherboards. Anytime you're dealing with e-waste, you're dealing with tin, because there's going to be solder, and solder is mostly tin, especially these days. It's almost 100% tin. So yeah, and tin always gets in the way of getting gold. And tin has just been in the way of everything I've tried to do with this stuff. So I'm going to work on a different method of trying to get rid of the tin today. Been doing pyrometallurgy, but I haven't been getting too far with that because it has not been eliminating the tin. So we're going to try something else to eliminate the tin today. We're going to get sort of a low-tech, back-to-basics type of thing and see if we can get a lot of the tin out of this stuff, okay? So I'm just going to take some of this stuff. I'm going to pour it out on this screen. This is a 10 to the inch screen. See if we can get some of this smaller stuff to go through. A big chunk of something, big lump. Break up that big lump. I'll give you a look at what's staying on top and what's going through. I got a feeling a lot of our problem is staying on top here. Let me zoom in for you so you can see what's going on here. So Jason's mill, when the motherboards, the circuit boards were run through, it smashed them up into pieces. And of course circuit boards have a lot of copper traces on them, and there's a lot of solder on those copper traces. And what Jason's mill did was it turned all of the metal, the malleable metal, the copper, the tin, into little balls here, and they got smashed flat at some point. And I'm thinking most of the tin is going to be in these balls. Some of these balls are going to be mostly copper, some are going to be mostly tin. A lot of them, if not most of them, are probably going to be a combination of the two. So I'm thinking that's where most of our tin is. And then what's going through is a lot of pins and wires. And a lot of these are gold plated. I don't know if that's showing up at all, but a lot of this stuff is gold plated. I can see it shining. So I think I may have separated out a lot of the tin here. Now I'm not just going to throw it away. Tin is valuable. These days the price of tin, you know, it's pretty high. And I get questions and requests from you guys all the time about how I would like to recover the tin from electronics. How am I going to recover the tin? How would you recover the tin? I get questions like that all the time. So we'll see if we can figure out a way to recover the tin from these balls up here, okay? And then maybe we'll look at ways to process this stuff down here, which I'm sure still has some tin on it, but it's not nearly as bad as it was, because I think most of the tin is going to be up here in this stuff. Okay, so I have transferred all those balls of metal that I sifted out to this other metal screen here. And what I propose to do, I'm going to spread them out a little bit. What I propose to do is put them in a put this in a cast iron frying pan and heat it up and see if we can melt the tin balls. And maybe they'll run through the screen down into the frying pan and separate from the copper and the steel and the other stuff that's up here. I don't know if it'll work. I got no idea. It's just a thought I had the other day. You know, I have my best ideas when I'm laying in bed just before I fall asleep and my mind is sort of freewheeling off in all kinds of different directions and just on the edge of starting to dream, and I have ideas. Well, this is one of those ideas that came to me. We will try that and see what happens. It might be a bust. It might be brilliant. Let's find out. Okay, so here's my cunning plan. May or may not work. We'll find out. I'm going to heat the pan from the bottom with my foundry furnace, and I'm going to heat the stuff in the sieve from the top with my propane torch, and we'll see what happens. So let me get this foundry furnace started and get things hot here. And once this heats up a little bit, I'll come back at it with the torch and see what it is stuff we can melt out and get to run down through the screen. And hopefully we'll have a puddle of tin in the frying pan. We'll see. Okay, this has had a chance to warm up. Actually, I turned the heat down because it was getting quite hot. I mean, I don't have a crucible in there. I'm trying to melt stuff in. The burner's not happy about running so low. So let's see what happens if I add a little heat from the top now. Ooh. Oh, we got smoke and green flames. So we got some copper there for sure. Upwind of all this smoke. It's probably not good for me. So far, I'm not seeing a lot of stuff melting. Maybe my cutting plan really isn't working. I don't know. I'm thinking there must be a lot of bits of fiberglass in there for it to be burning like this. Maybe embedded in those balls. Going out. have a map gas torch too. I wonder if that would work any better. I see the stuff turning red hot, but I don't really see anything melting. Okay, let me turn off the heat. Let me get my welding gloves, pull this out, and see if we've actually melted anything or not. Yeah, hot stuff here, hot stuff. Well, looks like a few drops of something did come through, but that's not a lot of tin. I think I actually see, ooh, hot. I think I actually see some molten tin in here. It's just not running down through the screen. Staying on top. Do I need coarser screen? I don't know. Yeah, I see some stuff here. Maybe. Or maybe it's something else. I don't know. Well, that didn't work. If you guys wanted to see the bloopers, the tests, the intermediate results, there you go. We got, yeah, there's some molten tin there. That is molten. It's liquid tin. I don't know if that's showing up, but that's liquid tin right there. So got some out, but not as much as I was hoping. So I need to think about that and see if I can come up with a better way to do it. Because that kind of, sort of, almost worked. Yeah, there's a few grams of tin right there. Got out. Give you a closer look at it. Still molten there in the still hot frying pan. Yeah, okay. So kind of, sort of, almost worked. Got a little bit of tin out of this stuff. We need to think about how to get more of it out. So as for this stuff, well, I think I've gotten a lot of the tin out of it just by sifting out those big balls of metal. But I've also got a lot of the copper out of it. So my main idea of trying to smelt this stuff into crude copper bars for use in an electrolytic cell, I don't think it's going to work with this stuff. I suspect this stuff is probably mostly iron. Let me check it with a magnet real quick. Oh yeah, look at that. So I think we got mostly iron here. A lot of it gold plated. And probably a little bit of other stuff. I'm sure some tin made it through. These pins are probably tinned or soldered at one point. So there's some tin that's made it through. Probably some silver in here too. So, what to do with this stuff? Well, I can think of a couple of possibilities. I could try smelting it. That's possible. Or I could try running this stuff through EcoGoldex and see if I can get a lot of this gold plating off. I am a little reluctant to do EcoGoldex though, because I have found that with finely divided material it will load up with base metal, tin, copper, that kind of stuff, rather than going after just the gold and the silver like it's supposed to. We have got a lot of the copper out of here though, and have got a lot of the tin out of here, so that's a possibility too. I've got enough material. We could try several different experiments and see what works best. So, yeah. I would like to stick with pyrometallurgy if there's a way to do that, because that's something anybody can do pretty cheap and easy. And, you know, I'm looking for ways to process this stuff. You know, you see me doing these small-scale experiments on this stuff, but what I'm really looking for is a way to process tons of it, okay? Efficiently, economically, environmentally responsibly, ways to process tons of it. So you see my little experiments and you think, oh, just do this, do that. Yeah, okay. On the small scale that might work, but it's probably not economical and it wouldn't scale up, you know? So I need something that's economical and would scale up a lot and still be economical and isn't going to create tons of waste that needs to be processed. So, you know, feel free to leave me suggestions, ideas. You guys have a lot of good ideas out there, you really do. But keep those criteria in mind. Think in terms of tons of this stuff and economy and environment, okay? So keep that in mind with your suggestions. Love to hear what you think. Let me know. Alright, how do you like the freshly painted workbench? I just put the last coat on it this morning and I'm already out here running some experiments trying to ruin it again. Yeah, it's had its annual paint job. I'm filtering some gold solution over here. There'll probably be some fresh stains and scuffs after today already. Well, anyway, you know, the Mythbusters used to have a saying. God, I missed that show. They used to have a saying. The difference between science and just screwing around is writing it down. So let's take some measurements, okay? I want to know... I cleverly forgot to weigh this stuff before processing, so we'll weigh it after processing. Let's see what we got here. Of course, it would help if I turned the scale on before I put stuff in it, wouldn't it? Let's see, what mode are we in? Alright. So I don't know if you can read that or not. Take my word for what it says if you can't. Get this stuff in here. Yeah, I really should have weighed it before I stuck it in here, but there's not a lot of stuff staying in the screen. It's all coming out. Okay, so that's 285 grams by the look of it. Okay, and let's see how much tin we actually got out of this stuff. Let me pull it out of the frying pan and not into the fire, onto the scale. So this kind of sort of worked, just not very well. So we got 2.81 grams of tin out of that material. And it's 285 grams, so basically we started with about 88 grams, around 288 grams. All right, and we got about 2.8 grams out of it. So the reason I'm doing this is because I have an idea for another method for separating the tin from this stuff, and I want to know which works better. So I'm going to have to acquire some stuff, though. I don't have what I need. And then we'll try my other idea and see if it works any better. Right around 1%. We got about 1% of the weight of that out of it this way. And I'm suspecting that tin makes up a whole lot more than 1% of it. In fact, I'll have to look at the assay report again and see exactly what it makes up. But yeah. So we'll see if we can do better with other methods. But it's a start. It's definitely a start. We're getting rid of some of the nasty tin that gives me no end of trouble. So I'm looking at this stuff that I ran through that melt. And I see a lot of thin copper pieces in here that are shiny with tin on them. But the tin's probably not thick enough that it's going to run off at the temperature, you know, that I got it to, or even at any temperature. Surface tension is going to keep it adhered on there. The tin's also kind of chemically bond to the copper to some extent. So I don't know how much tin I can actually get out of this stuff using this method, but I do want to try a different way and see if I get any more. But it looks like some of this stuff here, very thin pieces of copper traces that have been tinned, and the tin is thin. You know, it's not a big glob of tin like some of the stuff in here was, before I started, was globs of tin, and I think that's what melted and made this stuff here. I don't know how we're going to get rid of the stuff, the copper in there that just has a thin coating of tin on it. Got to think about that. See if I can come up with something. Let me know what you think too. Feel free to comment. Thanks. So I had another idea, which I don't know if I'm going to bother pursuing now. What I was going to do is take this fry pan, put it in one of my kilns, put a little mesh basket on top of it, and put all those balls of metal on top of this, and then heat the kiln up to about 500 degrees Fahrenheit or so, well above the melting point of solder, and see if anything drips through. But I'm thinking that, yeah, that's probably not going to work too good. There was too much stuff that was wicked onto that copper. So I don't know that I would get any tin in here. Oh, there's a little tin ball in here I missed. Didn't get it all. There's another one. Well, they're too small to really move the scale much. So, yeah, I'm thinking I need something to wick the tin off of that copper. You know, copper mesh would do that, but yeah, that's too expensive. It's just moving the problem to another piece of copper. So I was thinking about steel wool as a possibility. Yeah, so I was thinking, you know, make a bed of this stuff and pour all those balls of metal on top of it, heat it up in the kiln. Maybe this stuff would wick the tin away. That's a possibility. I might try that. But I had another thought. Too. Let me run something past the YouTube hive mind here and see what you think. So I've only managed to remove a little bit of tin from this stuff using, you know, the experiment I did earlier. Okay. But I did sift out a lot of the fines, and the fines were almost 100% steel. So I've taken a lot of steel out of this stuff. Okay? There's still a lot of steel here. There's no doubt about it. There's still a lot of steel in there. But I would imagine I have removed probably close to half or more of the steel that was in here originally. And I'm wondering if the steel, the iron in the steel, isn't what's causing me the problems with my smelting experiments. I wouldn't be the least bit surprised if that's the case. So I'm wondering if, you know, sifting the smalls out of this, the fines, and all that steel, if this would smelt any differently now. I'll have to think about that, whether I want to try smelting this stuff now. But I think what I want to do is I want to try some experiments with the fines. Because I know there's a lot of gold in the fines. I can see it. There's a lot of gold-plated pins there. So let's try some experiments with the fines. Okay, it's time to try something I've talked about a couple of times in past videos. And I've actually been trying it a little bit off camera. I know this was going to be experiments that I normally wouldn't do on camera and stuff, but I had the camera set up over for working on stuff for my second channel, and I didn't want to tear it all down. So I've just been working on this off camera, but you're going to see it on camera now. We're going to try some liquation, okay? So what I've got here is about 500 grams of lead. All right, 502, close enough. Well, 508, close enough for government work. So some of this lead has been used before. As you can see, it's been poured into my cone mold. So basically what I've got some extra lead here to make up for the loss a little bit due to oxidation. And what we're going to do is we're going to put this lead in this crucible. We're going to measure out 100 grams of this stuff that I sieved out earlier. This is the fines from that Mount Baker Mining and Metal stuff. We sieved out all the big metal balls, and this is the fines, and there's a whole lot of gold-plated pins in there. They're probably not showing up, but there's a whole lot of gold-plated pins in there, okay? So I'm going to measure out 100 grams of this stuff. just sort of an arbitrary number. You know, I might be able to do more. Maybe this is too much. We'll do some experiments here and see. 104, close enough, close enough. All right, so we'll put this in the crucible. And we're going to measure out, about 100 grams of borax. And the borax is basically there to provide a shield once it melts over the molten puddle of lead to prevent it from just oxidizing away to lead oxide. I don't want that to happen, at least not yet. Alright, close enough again. We'll put this in here. And I'm going to put this in the foundry furnace, and we're going to heat it up, get it all molten, stir it really good, and then pour it out into the cone mold. And what's going to happen is the denser lead is going to settle to the bottom of the cone mold, which will be the top of the cone once it's flipped out. The lighter steel and other metals in here will float on top of the lead because they're not as dense, and you'll get a stratification. But the precious metals in here, the gold and the silver, they should dissolve in the lead, and they should follow the lead. So they will wind up in the lead at the bottom of the cone mold. What I'll do then is I'll take that metal prill and I'll put it back in the crucible, but I'll only heat it up enough to melt the lead. And what we'll see is we'll see a parting between the lead and the other metals. The lead will make a puddle, and the other metals will stay there as a solid lump, which we can pull out. And hopefully, the lead will be enriched in the precious metals, the gold or the silver, platinum group metals, whatever. And I've already done this a couple of times. So hopefully, we're enriching this lead with precious metals. And then in the end, what we'll do is we'll cupel this lead and see what kind of a button we get left behind. Hopefully we'll get some decent amount of gold and silver out of it. It's worth a try. And it's easier to do with these fines because there's not a lot of tin in here, there's not a lot of copper in here, but there is a lot of gold-plated steel. And I'm hoping to strip that gold plating off, and it's going to wind up in the lead. So let's get this in the furnace and get this party started. Okay, get this in the furnace, we'll get this started. Now, I've still got people telling me in the comments to just dissolve everything away with acid. Okay, even after the last video came out where I did just that, and I showed how wasteful and inefficient it was. Yes, it works, but it took a whole lot of acid to get a little bit of silver, gold, and precious metals out of this stuff and generated a whole lot of waste. And it's just not practical on a large scale. Small hobby scale maybe if you don't mind dealing with the waste. But, you know, I'm looking for a way to do this with hundreds, thousands of pounds of this material. We run a lot of e-waste through Jason's system over there, trying to find a practical way to process this stuff. Dissolving it in acid, at least on that large scale, as far as I'm concerned, isn't going to work. But if we can find a way to concentrate all the precious metals into a small prill, maybe we can do something with that and generate less waste and use less acid and come up with something that's practical, economical, environmentally sustainable. But just dissolving thousands of pounds of it in drums of acid, that's not going to work. Not in my humble opinion, anyway. Okay, we'll let this get hot. Turn the heat up. Once it looks like it's all melted in there, I'll stir it up really good before pouring it out into the cone mold. Let me go get the cone mold. Everything's good and melted now. I'm going to stir it a couple of times before I pour it, just to make sure all of that gold-plated stuff manages to get in contact with the lead. And hopefully, the gold will dissolve in the lead. So I'll stir it again before I pour. But I got to heat up the cone mold first, so we'll get that going. so I don't have a steam explosion. That'd be bad. Okay, I think we are ready. One last stir. Forgot to put the cardboard on the plinth. Oh, it didn't stick too bad. I saw something interesting pouring that. It looked a lot like when I pour brass. I think there was some zinc in there that was burning off. I suspect. Okay, we'll let that harden up, and then I'll put it in front of the big fan and let it cool down, and we'll dump it out and see what we got. Oh yeah, good and cold. It's a chilly morning today. Doesn't take long in front of that fan to cool this thing down. Let's see what we've got. Yep, here we are. Let's take it over to the bench and check out a couple of things. Alright, so here's our prill. Let's see, we put about 500 grams of lead and 100 grams of the fines in there, so it's 614, so right about what we're expecting. There's still a little slag stuck on it, so that could be part of it. 610, that sounds more like it. Alright, so it's not magnetic at the top, but yeah, it's magnetic down here at the bottom. So what we've got is we've got the lead down here, and we've got the steel up in here. And hopefully all the precious metals have migrated down into the lead from the steel. So now what I need to do is put this back in the crucible, in the furnace, and only heat it up enough to melt the lead. And we should leave behind a chunk of steel as the lead melts away, and we can just pull that out and pour our lead back into the cone mold, and hopefully we will have lead that's enriched in precious metals, and the steel part will be depleted in it. And we'll just keep doing this a few more times till I use up all those fines, and then with the lead that's left we'll compel that down and see what we get. Crucible is still kind of warm from earlier, so this shouldn't take too long to melt this down, since we only have to heat this up to the melting point of lead. We don't want to remelt that steel. So this should only take a few minutes. And I'll be able to pull that slug of steel in the bottom out, and then pour the lead back in the cone mold. Let's see if that steel's ready to come out of there. Looks like the lead's mostly melted. Yeah, there it is. Shake the lead off of it. There's our slug of steel right there. And then the lead's ready to pour. Oh, wait a minute. There's another slug of something in there. Yeah, one corner came off the steel. Okay. Get this lead poured back in the mold. And we'll use it again. Lose a little bit to oxide every time with this second process. Thinking maybe it would be better to skim the stuff out from under the borax layer rather than doing this, because we lose some lead to oxide every time I have to do a little bit of makeup lead with each batch. So, got to think about that. Okay, let's look and see what we got here. So, here's our prill of lead after repouring the lead out. Didn't lose that much. A little over 100 grams of lead. And there's still some stuck in the crucible, but there's a lot of oxide in there too. And then here's our steel plug. It's got some lead stuck on it. It's got a lot of lead oxide on it. That together, they add up to about 500. So yeah, we lost about 100 grams of lead, which is about normal when I do this. And I suspect it's all going to oxide and staying in the flux. Save the flux, by the way. We're going to process that down the road. But, yeah. So we put 100 grams of the fines in there. And we got 114 gram slug of steel. So, yeah, there's a little bit of lead stuck on it. There's some lead oxide stuck on it. There's probably some borax stuck on it. So it's a little heavier than what we started with. But got most of our lead back. And hopefully our precious metals are in there. So the theory behind liquation is you take about 1 part of the material that contains your precious metals and about 4 to 5 parts of lead. You put them in the crucible and you melt them, okay? So if you start with 1 part of your material with precious metals and 5 parts of lead, you've got 6 parts of material there, okay? So assuming that the precious metals were to be equally distributed through all 6 parts, then once you separate the lead out, you're going to get 5/6 of the precious metals concentrated in the lead. That's the theory, and that's assuming that your precious metals are going to be more soluble in the lead than in the steel, and that they don't go into the flux and whatnot. So, you know, we may not be doing quite that well. We may not be getting 5/6 of the precious metals here. But what I'm going to do is I'm going to keep reusing this lead. So I've already done it about 3 times. But I'm going to keep doing it until we get at least 4 or 5 times I've done this with this lead. And then we'll compel it down and see what we get. I'm pretty sure I saw zinc burning off earlier. When this stuff was so hot during the first pour. So we probably concentrated zinc in here. We've probably concentrated copper in here. We've probably concentrated tin in here. But I'm hoping that once we get to the compelling stage, all of those materials, all of those metals will oxidize away and their oxides will just be absorbed by the compel. That's what I'm hoping. I'm not sure it's going to work that way, so we'll have to find out. But hopefully, our gold, our silver, our platinum group metals are getting concentrated in the lead. And as I keep doing this, hopefully they're going to get more concentrated. So, let me do it again. Okay, one more time. Actually, this is going to be the last time. I actually doing a larger batch this time, more lead, and the rest of the sifted stuff of the MBMM material. So, yeah, this should be the last time for this. Then we'll see if we can get some precious metals out of this lead. This stuff melted down, poured, and then melt the lead off again. Just like before. So I don't know if you can see the white smoke coming out of there, but that's another indication to me that we've got some zinc in there. That's white smoke is probably zinc oxide coming out of there. The zinc's burning off. So I looked at the assay report again. There's almost as much zinc in there as tin. And zinc causes some problems too. The silver is going to be a lot more soluble in the zinc than it is in the lead. And the zinc's going to float on top of the lead. So we may not get all our silver into the lead. Not sure about the gold. I'm not sure whether gold's going to follow the zinc or the lead. But this could cause some complications. But this is an experiment. There's no guarantee it's going to work. I'm going to try it and see if it works. So we're just about ready to pour. I'm going to give it another stir. And we'll pour this stuff. Oh, I would say there's definitely some zinc here. This has the classic look of zinc boiling off. That could be a problem. Oh yeah. That looks like zinc boiling off. Well, we'll just have to see what happens. Okay, this has had time to cool down. Let's see what we've got. By the way, I'm saving all of the slag from all these experiments, and it may be processed in the future to see what I can recover from it. I'm sure there's probably some lead oxide in this borax. Alright, let's weigh this up just for funsies. Okay, let's weigh this thing up. This is the biggest one I've done yet because I wanted to use up the last of the material without having to go through 2 pours. So yeah, 918 grams. So yeah, that's quite a bit bigger than the last one. And as usual, we got the steel at the bottom, but not at the top. So let me get this back in the crucible, melt the lead off, and pull the steel slug out. Okay, let me get this slug of steel out of here. Shake off as much of the lead as I can. There's still some stuck to it. Hard to get it all off. See it oxidizing peacock rainbow colors as it comes out. There's a little bit of lead stuck on there still. Oh, I even used cardboard this time and it's still stuck to the flint. Alright, that looks pretty good. So, I think that's going to be the last one. Let's figure out how to oxidize away this lead and see if there's any precious metals in it. And by the way, I am keeping the steel slugs just in case, as I mentioned, the zinc winds up causing us problems and a significant amount of the silver stays in these. Okay, gotta let this cool down and dump it out and then figure out what to do with it. Okay, let's see how much lead we've got here. That is one shiny ingot too. I don't know if the shine is showing up on it. Wow, that is shiny. So 644 grams of lead. I did add extra lead for this last run just because I added all the rest of the fines in there. So I guess I need to figure out what I'm going to do with this great big chunk of lead here. Lead and mixed base and precious metals, I'm hoping. Yeah, don't have a decent cupelling furnace. I could try cupelling it in my foundry furnace. That's probably the best option, but well, I don't have cupels this big. I could melt it down into smaller batches, but boy, 646 grams. What is that? 12, 13 of my small 50 gram cupels. Yeah, that seems a bit too much trouble. Let me give this some thought, and we'll see what I come up with in the next video for dealing with this stuff. I think I'm going to end this here. So thanks a lot for watching. Always leave comments and suggestions, constructive criticism. I'm always open to that. And we'll see what I come up with by next time. So subscribe to see those future videos. Check out my second channel, Electric Geek 64. There's good stuff going on over there if you're into electronics and retro computing, so check that out. And I will see you in the next video. Thanks a lot for watching this one. Bye.